Today we will revise the next part where the types of combustion is there. So everyone open page number 69 in your science textbook. Page number 69. Okay, now look at this. The subtopic is that type of combustion. Now, the combustion is divided in three classes, that is the rapid combustion and spontaneous combustion and explosion. We can divide it into three parts: combustion, rapid combustion, spontaneous combustion and explosion. Okay, three kinds. Now, already we have defined earlier the definition of that. Just one time revision of the previous one. So, what is rapid combustion? We find that gas burns rapidly and produces heat and light. So, the burning of gas is the types of combustion which is called as rapid combustion. So, it is the burning of gas to produce heat, light. This is rapid combustion. Next one, there are substances like phosphorus which burn in air at room temperature. Okay, so this is very important that the phosphorus which is burned in air, that is in room temperature. On previous discussion, I have told you that some of the chart regarding the combustible point or ignition point, there the phosphorus is very low, that is white phosphorus is just 35 degrees centigrade. Okay. Next one, type of combustion in which a material suddenly bursts into flame without the application of any heat is caused as spontaneous combustion. So, spontaneous combustion is that it is spontaneous and no apply of heat is there. So, combustion without supplying heat. Okay. So, the example of that spontaneous combustion, that is might be that the burning of phosphorus, burning of white phosphorus, burning of white phosphorus. This is one example of spontaneous combustion because no heat is applied here. Next one, spontaneous combustion of coal dust has resulted in many disastrous fires in coal mines. Spontaneous forest fires are sometimes due to heat of the sun or due to the lightning strike. However, most of the forest fires are due to the carelessness of human being. It is important to remember that the campfire must be completely extinguished before leaving a forest after a picnic or a visit. Next, the number 3 is that we generally have fireworks on festival days when the crackers is ignited. A sudden reaction takes place with the evolution of heat, light and sound. A large amount of gas form in the reaction is liberated. Such a reaction is called explosion. So, how explosion is defined? So, it is also a combustion. It is also a combustion where the heat, light and sound, where heat, light, sound produced. And another one is that what is the reason behind this? A large amount of gas is produced, due to which as it is suddenly burned or suddenly combust, then it produces the lots of energy at the same time. So it is due to the formation of the gas. A large amount of gas is formed suddenly. This is due to the reason of the burning. So three kinds. One is rapid combustion, where gas burns rapidly. Another one, spontaneous combustion, that is burning of white phosphorus, combustion without applying of heat. Okay. Next one, that is explosion, combustion, where heat and sound and also the light is generated. Now here some point of distinction is there in between the rapid combustion and spontaneous combustion, in between the spontaneous combustion and explosion, and in between rapid combustion and explosion. Just the definition is the one of its distinction. Now here a large amount of gas is produced in case of explosion, but in that too it is absent. Here no supply of heat is there from external source. So it is the natural process, the spontaneous process. So the forest fire is also example of spontaneous combustion. The mines, the coal mines, etc., the fire in coal mines is also an example of spontaneous combustion. Now rapid combustion, that is here the gas burns rapidly, where the explosion, here some substance suddenly burns to produce the heat, light and sound. So these are the points of distinction, and also you will mention one of its example with this distinction. Okay. So it is a very important part of this chapter, that is types of combustion. Next, move to flame. Now just I am going back to explosion. So you can see that when a substance explode or when a crackers burst, then what happens? We can see an area. Suppose this is the size, and we can see an area where this is the area of fire when it's explode. So this area basically having fire. Why this is this fire produced in that? Because of this gas produced from that substance is suddenly burned to produce the fire, or another name of this is called as flame. So it may be due to the formation of any gas, or it may be due to some volatile substances when combust are produced. So for example, when a candle is lightening or a candle is glowing, it is due to the volatile substances which is produced due to the heat. Okay, and it is coming out through that stripes. Through that thread the vapors are coming out in the form of a viscous matter or in a heavy concentrated form, and it is helps to burning that we can find out in the form of flame. Okay, now look at this. Observe an LPG flame. Can you tell the color of the flame? What is the color of a candle flame? Now what is the color of the flame when a gas is burnt, that is LPG is burnt? Can you tell me what is the color of that flame when LPG is burnt and when candle is burnt? Now we are moving to the combustion, that is incomplete combustion and complete combustion. Complete combustion and incomplete combustion. Yes, LPG blue, candle is yellow. So the LPG is blue and candle flame, that is yellow. Okay. Now anyone can tell me that what is the materials or what is the element for which a substance burn? What is the reason behind it? What is the core component of burning? No, it is not heat. What is the element? Fuel, yes. Fuel, more specifically, this is carbon. More specifically, it is carbon. That the reason behind the combustion. If carbon is absent, no combustion will be there. So the core element is carbon, which is present on each of the substance or each of the combustible substance in different amount. Okay, so this is carbon. Okay, now the reason of two colors of flame is due to the different combustible level of that particular material. Okay, so the different color is due to, one is due to the complete combustion when it comes with blue flame, and when the incomplete combustion is there, it comes with a yellow flame. So incomplete combustion means the combustible substance are not totally burned, but the complete combustion is that the substance, the combustible substance, or the amount of combustible substance present on it are totally burned. Okay, so the complete combustion or blue flame is the reason is that it is completely burned or the combustible material completely burned, but in incomplete combustion it is partially burned. For this it comes with a yellow flame. Understood? What is the reason behind this? That is incomplete combustion and complete combustion and blue flame and yellow flame. Okay. Next, table 6.2, material forming flame on burning. Candle, the material forms flame, does not forms flame. Now, candle also forms flame. Magnesium, it forms flame. Camphor, can you tell me camphor forms flame or not? Camphor, does it form flame? Forms flame. Okay. Next one, kerosene stove, is it form flame? Yes. Charcoal, is it form flame? Yes. Now the only substance, now some of the books also shows that carbon forms flame. I think most appropriate will be that it does not form flame. Okay. So when a charcoal is burned, it just glow but do not form any kind of flame. So all of these except charcoal forms flame. Next one, 6.5, structure of a flame. Now structure of a flame, it will be clear, just turn your page, that to page number 72. Okay, the substance which vaporizes during burning. Now I am telling you that what is the vaporizes or the substance which forms the vapor will gives you the flame. For example, kerosene oil, molten wax rise through the wick or are vaporized during burning and form flame. Due to this, through this wick, I have earlier drawn here. On the other hand, which does not vaporize and do not produce a flame. So, which does not vaporize, it will not produce any kind of flame. Okay. When the candle flame is steady, introduce a clean glass plate or slide into the luminous zone. Now, in the next page, we will define the luminous and non-luminous of the flame. Hold it there with a pair of tongs for about 10 seconds, then remove it. What you have observed, you can observe that some black spots is formed on the part of that which is contacted with the flame. Why this the black spot? It is the incomplete combusted carbon or incompletely combusted substance, which as they are not combusted and as it got stuck by the glass plate or the slide, it will represent in the black form, because carbon is of in black nature, black color. A circular blackish ring is formed on the glass plate or slide. It indicates the deposition of unburnt carbon particle, okay, present in the luminous zone of the flame. Now, what is luminous and what is non-luminous? Now, turn over the page. Now, the flame is basically classified as three parts. One is the outermost zone, which is blue layer. Another one is middle zone, that is partial combustion, which is of yellow color, and innermost zone, which is unburned wax vapor, which is black. So, three zone is there. One is the outer zone, which is blue, the middle zone, which is yellow, and the innermost zone, which is black in color. And what is luminous and what is non-luminous flame? So, luminous flame that having some unburned carbon particle, that is, from there we can tell that the yellow color of the flame representing the non-luminous zone, and the luminous zone, and non-luminous zone, that is completely combusted area, that is the blue flame representing the completely combusted, or it is the non-luminous zone. So, non-luminous zone, which is blue in color, and luminous zone, which is yellow in color. Now, there is a point why Goldsmith uses the outermost zone, because it is the highest temperature zone. What is a fuel? Any combustible substance that having some heat value is called as fuel. Okay, that's all. On the next day, we will start from what is a fuel. Okay, so up to this, you will prepare your lesson. Okay. Thank you everyone. Just wait to take your attendance.